This video aims to show general applications of the dot product within engineering mechanics. The main two applications of the dot product in engineering mechanics are to find the angle between two vectors and also to find the projection of one vector onto another. To find the angle between two vectors, we use the formula theta equals cos inverse A dotted with B, both vectors, over the scalars of A multiplied by the scalar of B. This formula lets us find the angle that is between vector A and vector B that is less than 180 degrees, or the smaller angle of the two vectors. This formula can be derived from the original formula of vector A dotted with vector B equaling AB cos theta. Rearranging for theta, we get the original form that is just above. To solve this equation, we need to use the formula we discussed earlier, that is, to be able to dot two Cartesian vectors together in the form of AX, BX, AY, BY, AZ, BZ. This form then gets substituted back up into this equation here, and then can be solved by finding the scalars of A and B and then solving in your calculator. The other main use of the dot product in engineering mechanics is the projection of a vector onto another vector. What is meant by this is how much an arbitrary vector is pointing in the direction of another vector. In the first diagram, we can see that the vector of interest is vector A, and that we are finding how much this vector is projected along the x-axis. The second diagram looks at a simple 2D case whereby a vector A is being projected onto the blue line pointing in the direction of the unit vector. Also note, with this method, it is also possible to find the projection of a line that is perpendicular to the projection which you are interested in. To find the projection that you're interested in, you use the formula A projected is equal to A dot U. A is a vector, and it's the vector that you're interested in. U is also a vector, but it's a unit vector in the direction of the projection that you're interested in. Note that this will find you a scalar or a magnitude of the projection that you're interested in. To find an actual vector that has a direction, you need to do the same thing, dotting these two vectors together, but then also multiplying it by the unit vector again of the direction of the projection. To find a vector that is perpendicular to the projection that we found earlier, we need to take advantage of the formula A, the original vector, is equal to the perpendicular vector that we're trying to find plus the projection that we just found. Using algebra, we can rearrange this formula so that the perpendicular projection is the subject, and this is equal to the vector that we are given minus the projection that we have found. By now, you've probably realised that you could use trigonometry to find the projections in this 2D case. When doing 3D cases, it is a lot harder to try to use trigonometry. Therefore, it is recommended to use the dot product method to solve the projections and perpendicular projections.